those of you who take calculus. So they're pretty easy. They literally are telling you the sign of something, meaning positive or negative. So if I said solve f of x is greater than or equal to 0, and f of x was the function x minus 1 squared times x minus 7 times 3x plus 5, and I asked you to do this algebraically. Algebraically is just a phrase that would mean that you would need to do this using algebraic methods, not graphing. And so the way we solve something algebraically today is called a sign chart. And a sign chart is really easy to do. What you're going to do is you're going to make kind of like a number line, and on the number line you're going to put the zeros. And the good thing about the zeros is they're right here for us to see because this is in factored form. So on my sign chart I put the zeros, and I want to put them from left to right. This is not like a graph. This is just, think of it as like the x-axis, okay? From left to right of these things, would we agree that there is a 0 at 1 and at 7 and, let's find this one. Where does 3x plus 5 equal 0? What would I do to solve that? Minus 5, divide by 3, right? So negative 5/3. Isn't that negative 1 2/3? Yeah, okay. That's important. So would you put on here negative 1 2/3? We're going to put our zeros from left to right because that's the sequence of what we put them in does have to match what an x-axis would. You don't have to put a scale on that. What would be the next 0 as I move to the right? 1 and 7. So what the sign chart does is it breaks it into different intervals. So we have an interval over here, and then we have another interval here, and one from 1 to 7, and then from 7 to infinity. And so our job is we are going to figure out what the sign of the function is on all of those intervals. So I start to the left of negative 1 2/3, and you may pick anything to the left of negative 1 2/3. The reason why I picked these numbers is because didn't we agree on Friday that where something touches the x-axis, isn't that where it changes signs? Potentially. Okay. So a sign chart is just saying, hey, well, what's the function doing over here? And this function goes for till negative infinity, so I can pick anything to the left of negative 1 2/3. I like to pick a whole number that's easy to work with. So I'm going to pick negative 3. And what we decide is we put negative 3 in and we don't evaluate it. We just tell ourselves, is this a positive number or a negative number? If you put negative 3 into this first parentheses and then you squared it, what kind of sign would it have? Positive. When you square something, isn't it always positive? So I have a positive number times, what if I put negative 3 into the second factor? Positive or negative? Negative. And what if I put negative 3 into here? Would this be a positive or a negative? Negative. And then we just ask ourselves, what's a positive number times a negative number times a negative number? It's a positive. Would you put a plus sign and would you circle that? What that means is the function to the left over here of negative 1 2/3 is positive here. Then we keep going. Now I need to pick a value in between negative 1 2/3 and 1. What's a really easy number to work with? 0. I'll pick 0. So let's put 0 into this first parentheses. If I said 0 minus, square it, what is that? Positive or negative? Positive. How about 0 minus 7? Positive or negative? Negative. 3 times 0 plus 5, positive or negative? Positive. So I have a positive number times a negative number times a positive number. Over here it's negative. I'm going to put it just kind of down here, just to keep track of which ones are negative and positive. All right. Pick something for me between 1 and 7. Any number you want between 1 and 7. 5. I think we established if I'm squaring something, isn't this first one always going to be positive? Yeah. How about 5 minus 7? Positive or negative? And how about 3 times 5 plus 5? Positive times positive, it remains negative. Why is that not a surprise to some of you? Because I heard somebody say it bounces there. And how could they tell it bounces? Because it's even multiplicity. And lastly, I'll pick 8. If I plugged 8 in, that would make the first factor positive, the second and third, that's positive. So this is our sign chart. We didn't even have to graph it to know. Just had to pick some values and evaluate if it was positive or negative. Let's answer the question. The question is, solve f of x greater than or equal to 0. So I am going to highlight the intervals where the function was positive. It was over here and over here. So those intervals are from negative infinity to negative 1 2/3. Is at negative 1 2/3 it's equal 0, right? So we're going to include that in our answer. And then also after 7. So from 7 to infinity. So this would be my solution. Okay, does that make sense? A little sign chart. Okay, then what we're going to do is we're going to do one more. That is a rational function. And the sign chart for a rational function just has one extra thing on it. So we're going to make a sign chart. And we're going to solve x plus 1 over x squared plus 2x minus 3 is less than or equal to 0. Okay, so I already told you that on a sign chart, or yesterday or Friday, that where something changes signs is the zeros. Another spot where a function changes signs is at an asymptote. Because a lot of times we have an asymptote and the function was up here and then it moves to down here or vice versa. So what we're going to do for sign charts when you see a fraction is you're going to put the zeros, the 0 is where the top is 0, and the asymptotes on your sign chart. So I think we need to factor first, don't we? Let's factor the bottom. What does the bottom factor into? Any ideas? Multiplies to be -3. -1 and 3. So x minus 1, x plus 3. Okay. So then on my sign chart, I am going to put a 0 and an asymptote, and just to keep track of which is which, I'm going to write 0 and asymptote by those. If you want to use abbreviations like Z and A or undefined, that's fine. So -1, -3, and 1 are the things I'm going to put on there. Which one occurs furthest to the left? -3. Is -3 a 0 or an asymptote? How do you tell? Who remembers how to tell if it's a 0 or an asymptote? I gave you a little cheat sheet if you need to take it out. Don't be shy. Muhammad, 0 or asymptote? What do you think?
0.
Okay, so where is it, top or bottom? You want to change that? So when they're on the bottom, they're asymptotes because remember we can't divide by 0. So I'm going to write here for the -3, I'm going to write that that's undefined. Undefined. All right. Left to right, the next one that would occur would be -1. It's on the top, so -1 would make the function 0. That just means I'd include it in my answer. And then the last one would be 1, and that's an asymptote or where the function is undefined. Okay. Now don't overthink this. If you're dealing with the fraction, it's all multiplication and division. An even number of negatives makes something positive. Okay, even with division involved. All right, who wants to volunteer to pick a number? It's like the easiest job of the day. -4, thank you. So what we're going to do is we're just figuring out the sign of this, this, and this. If you put -4 in the top, would that be a positive or negative number? If you put a -4 in for x, with the top negative, okay. Over, if you put a -4 in this first parentheses on the bottom, would that be positive or negative? Negative. And then times would make that negative. 3 negatives with multiplication and division means that the result is a negative. It's an odd number of negatives. Okay, I'll pick -2. I put -2 in the top, it's still negative. I put -2 in this first parentheses, it is negative. I put -2 in this second parentheses, that makes this positive. How many negatives do I have in the expression? 2. That's an even number of negatives. That means in between here, the function is positive. I am going to pick 0 here. I put 0 on top. 0 plus 1 would be a positive number. 0 minus 1 would be a negative number. And 0 plus 3 would be a positive. I see one negative sign that makes the whole thing negative. And I'll pick 2. 2 on top makes that positive. It makes x minus 1 positive, and it makes x plus 3 also positive. Over here, the function is positive. Okay, this is why I had to label things though, because I want to find where this is less than or equal to 0. So I am going to include the zeros, but I'm not going to ever include asymptotes. So I'm going to highlight the places where the function is 0 or negative. So I have over here, but I don't highlight the -3 because that's undefined there. I also have over here So I'm going to highlight the negative 1 because I want to find when it's less than or equal to 0, but I don't highlight 1 because it's undefined there. So then I put that together to answer my question. The function is less than or equal to 0 from negative infinity to negative 3. Don't include the negative 3 because it's undefined there. And it's 0 at negative 1 up to 1. So include negative 1, but not the 1. This would be your solution. The sign chart is not your solution. The sign chart helps you find your solution. Okay. Love sign charts. One of my favorite things. But I'm weird, we've established, you know. Math teachers are weird. Love sign charts, though. They're so much fun. What's that? Yeah, we're all weird. We all are weird things. Quirky. That makes it sound nicer. All right, what if I wanted to check my answer? Could I graph it? Yes, you can graph it and kind of confirm. So if I would put this in my graphing calculator, I'm going to put it in and not in factored form because otherwise I have to have extra set of parentheses. Okay, there's my graph. Remember, I'm looking for where it's less than or equal to 0. I can see here it's negative over here. That's my first interval, negative infinity to negative 3. Okay. You can't see that because of the glare here. I'll move it down. And then it goes to positive, but then it crosses here and it's negative again. And that was the negative 1 to 1, because after 1, the function becomes positive again. Okay.